Hello and welcome, strange people of the internet. I am Kiara Blows. I am a biomedical sciences student at Newcastle University, and I'm going to be your physical sciences tutor with Tutorbox Live in conjunction with COVID-19 catch-up courses. So I hope you are as excited as I am to get our think on. This lockdown is just, you need to engage your mind. Right, we know that. So I know a lot of people are very intimidated by physical sciences, and it is said to be the most difficult subject, maybe. And it definitely does have its difficulties, but I think you just have to know what to look out for, tips and tricks, which I will definitely share with you. And who knows, maybe you'll get the marks you've always wanted, which I believe in you 100%. And so I just wanted to I'm so proud of you for taking the time out of your day to sit here and listen to what I have to say, because I'm not a very interesting person, but I can help you with science, so we'll go with that. And yeah, so grab your notebook, probably your worksheet that you were sent with us, some writing materials, your willpower and your brain, and perhaps a very caffeinated beverage, and let's get started. And we're back with lesson 2, chemistry, matter and materials. Okay, so my name is Kiara Blows and I am going to be your Tutorbox tutor. So this is just a little diagram. You can write it down if you want, and just a basic summary of what we're gonna cover. That matter can be split into mixtures and pure substances. Your mixtures can be split into your homogeneous and heterogeneous. Your pure substances can be split into your compounds and elements. Your elements can be further split into your metals and your metals and your non-metals. There's also metalloids, which we will cover as well, and that your metals can be split into magnetic and non-magnetic. So what I would recommend you do is grab a white piece of paper and draw this up pretty big with enough spaces, and that way you can just make little notes under each section. That's what I would recommend doing, just to summarize this whole lesson almost onto one page, and if you need to go over onto the other side. So first, we're going to go into a bit more detail on classifying your matter. So we're going to go into mixtures first. So a mixture is a combination of two or more substances where these substances are not bonded and no chemical reaction occurs between these substances. The substances that make up a mixture are not in a fixed ratio, they do not lose their physical properties and can be physically separated. So for example, if you take some sand and some water and you mix them together, you're going to have a mixture. It doesn't matter how much water you have, and it doesn't matter how much sand you have, you are still going to have a mixture. Okay. A heterogeneous mixture, so remember, hetero means different. So that's why it's non-uniform and there's two or more substances. That's why it's non-uniform. And you can see the different components of the mixture. So for example, if you mix together salt and pepper, you will be able to see that there's two different things in them, and you can see which parts are pepper and which parts are salt. A homogeneous, so homo means same, so that is uniform, where the different components cannot be seen. So for example, once you bake a cake and you put it in the oven and you slice it, you cannot tell that that part is an egg. Okay. Furthermore, your heterogeneous, so your two substances, can be further separated. Okay. So we've got liquid, liquid, solid, liquid, and gas, solid. So remember, there are three phases of matter. These are the names. So a liquid liquid is called an emulsion. A solid liquid is called a suspension. A gas liquid is called an aerosol, so that's your deodorant. And a gas solid is a smoke. So an example would be oil in water is an emulsion of a liquid liquid, and it's separate. You can see each part of the components. A solid liquid would be your muddy water, because the mud is your solid and the liquid is your water. A gas liquid would be things like fizzy drinks, spray deodorants, those type of things. Your gas solid would be something like smog. Okay, happy with that. Now we're going to move on to the second branch, which is pure substances. So we've covered everything for mixtures. So just to reiterate, mixtures are split into homo and heterogeneous mixtures, and your hetero can be further split. And that's all your classification goes on that side of your branch. Your pure substances, on the other hand, are any materials which are not a mixture. Okay, and those are either your elements or your compounds. So you need complex chemical methods to break them down. You will use your melting and boiling points and chromatography to test for these pure substances. So pure substances will have a sharply defined melting and boiling point, whereas impure substances will melt or boil over a range depending on their components. Because obviously a mixture of muddy water is not a fixed mixture. You can have different ratios, remember. And then just what chromatography is the process of separating substances into their individual components. So you don't really need to know this, but you can have different types of chromatography. Okay, further, what is an element? A substance that cannot be broken down into other substances through chemical means. Whereas a compound is a substance made up of two or more different elements that are joined together in a fixed ratio. Very, very importantly, it has a chemical formula. This describes the ratio, can't speak English today, in which the atoms of each element in the compound occur. Okay, so I want you to take down this table, and then I shall fill in the answers with you. I'm going to give you probably about 2 minutes. Alright, so I'm back and I hope you attempted these questions. Very easy, and I hope you had a chance to look at all of them. Okay, so our first one is, just get it in front of me. We had to tick whether each of the substances is a mixture or a pure substance, and then if it is a mixture, say whether it's a homogeneous or heterogeneous mixture. Okay, so physical drink would be a mixture, correct, and it would be a heterogeneous. Okay. Steel is actually a mixture. I know that sounds a bit weird, but it is actually a mixture. And it is a homogeneous mixture because you can't tell that there's different parts not chemically bonded. It's a very weird one, but it is a mixture. Oxygen is a pure substance. Iron filings are pure substances as well. It is an element, even though it's been filed down. Smoke is a mixture, and it is a heterogeneous mixture. And limestone, this one depends. Generally, limestone is not just pure limestone, so it would be considered a mixture. However, we're just going to take, given that they gave us the formula, that it would be a pure substance. Okay, and then number 2, which of this following substances are an element, a mixture, or a compound? So A would be element, B would be mixture because it doesn't give you that they're bonded. And if they were bonded, it would be iron sulfide. So we know that they're not chemically bonded together, so it's a mixture. C is an element, D is a compound, and so is E. So I hope that was good. And now we're going to go on to the name and formula of substances. Moved on to the name and formula of substances. So the compound name will always include the names of the elements that are part of it. Remember, in the example we just did, sulfur becomes sulfide, bromine becomes bromide, and chlorine becomes chloride. That's how you know it's part of a compound and not just a mixture. In a compound, the element that is on the left of the periodic table is used first when naming the compound. Okay, the symbols of the elements can be used to represent compounds. That's called your chemical formula, and they showcase the ratios. If you've got H2, we've got 2 hydrogen atoms, and then if it's O, we've only got 1. A compound may contain ions, which can either be simple, so only one element, so H2, or N2 gas, for example, or compound, consisting of several elements, so that would be H2O, NH3, etc. Prefixes can be used to describe the ratio of the elements that are on the compound. This is used for nonmetals. For metals, we add a Roman numeral 1, 2, 3, and 4 in brackets after the metal ion to indicate the ratio. Okay, this is just because some metals can have different types of valency, so they can bond differently. Okay, I think we will go into some examples, and then prefixes to describe the ratio of the elements. So that would be like 2H2O, for example. And then the following prefixes, mono, di, and tri, should be fairly familiar. So a well-known example is H2O. The full name is dihydrogen monoxide, but nobody really says that, but that's where the prefixes come in handy. Okay, so we're just going to go through this one. The formula of calcium carbonate is CaCO3. Is it an element or a compound? So we know it's a compound because it's consisting of 3 different elements. Okay, what is the ratio of the atoms in the formula? So we've got 1 calcium, 1 carbon, 3 atoms, so you would write 1, 1 to 3. Okay, give the names of the following substances. So we've got potassium bromide, we've got hydrogen chloride. This is your potassium, and this is actually a ion that we're going to come up next time. So I won't go over that one, just write that down so we can do it once I've discussed the ions. This one would be nitrogen dioxide. This is ammonium, and this is hydroxide. So this is ammonium hydroxide. This would be disodium sulfate. This would be iron nitrate. Pb is lead, so lead sulfite. And then this would be copper carbonate or dicarbonate. So I know I've skipped out some of the atoms, but it's just to show you what they are. But we haven't really covered the ions yet. So now we're just going to go over the ions very briefly. Okay, these are your cations and your anions. So if you know which ones are positive and which ones are negative. And some of them are just the actual like elements, so fluoride, chloride, bromide. But some of them are special, if that makes sense, that you have to know. So permanganate, chlorates, phosphates, and whatnot. These are the formulas. So these are all your positive and these are all your negatives. Okay, so you've got hydrogen, potassium, copper, magnesium, tin, manganese, nickel, aluminium, cobalt, and I hope you've noticed that they have the 3 and the 2 or the 1. Okay, oh, that's a 2, sorry. And that relates to your charge. Got lithium, silver, which is Ag, ammonium, calcium, lead, 2, iron 2, copper 2, chromium 3, chromium 4. So this is where I was talking about. Oh, so that's 6. Where knowing your Roman numerals is also pretty important, but it can exist as various forms. Got sodium, mercury, beryllium, barium, chromium again, this time it's 2, cobalt, we had there as well, zinc, iron, and I think we had iron there as 2. Okay, so iron will be your most common one dealt with, that you have to remember that it's Fe2 or Fe3. Okay, make a note of that. And manganese again. Okay, so that's why they have to have the Roman numerals in the brackets, because they exist in different forms. Then your negatives. So your negatives are generally the ones that change name. So we've got fluoride, chloride, bromide, iodide, hydroxide, nitrite, and nitrate. The difference is in oxygen. Hydrogen carbonate, hydrogen sulfite, hydrogen sulfate, dihydrogen phosphate, hypochlorite. I think there's another name for this, depending on your textbook. Chlorate, permanganate, and acetate. This is quite a long one, but it comes important when you deal with acids and bases later on. Oxide, perioxide, carbonate, sulfide. So that's just your normal sulfite. This is sulfite, which has an oxygen, sulfate, thiosulfate, chromate, dichromate, manganate, oxalate. This one's not that important. Hydrogen phosphate, nitride, phosphate, and phosphide. So I know that seems like a lot of overwhelming information. You don't obviously have to know all of them, but it's just nice to have a nice summary. So if you would like to make notes of any of them that you think you'll struggle to remember, or just make a note that you need to look up these ions. Okay, so that brings us basically to the end of our concepts of part 1. What I'm going to do is I'm going to attach a screenshot of a chemical formula writing worksheet. This is a bit in depth. There are some things that you won't really know about yet. So I encourage you to take a few minutes to try and complete it on your own. You can always, after this, get a friend and check your answers. Or send it to a friend and challenge them to do it, and then you can compare. You can obviously always look up your answers online, so this is just a little bit of an extra resource to make sure that you consolidate all this information. I'll leave it on the screen for about 2.5-3 minutes, and then you should get a little break, and then we can jump into part 2. So I hope you enjoyed this part 1, and I hope your mind is a little clearer on some of these little niggling concepts. If you have any queries on this part, do make a note of them, and I will answer them in your Q&A. Have fun with the worksheet until we start part 2. that was information overload, but we're going to go on just because this is just a bit of the basics, so we can get into more exciting stuff later on. So metals, metalloids, and nonmetals. Oh, exciting. The names tell you everything. So the elements in the periodic table can be divided according to whether they are metals, metalloids, and nonmetals. So metals, metalloids, and nonmetals all have their own specific properties. So your metals are found on the left, your nonmetals are found on the right, and the line that separates them are really your metalloids. So the zigzag line separates all the elements that are metals from those that are nonmetals, and they obviously all have their own properties, which is why we classify them as such. So what are these properties? So this is a nice summary table just summarizing the basics. If you've taken my advice and drawn the A4 metals, metalloids table, you can just add a couple notes under there. Otherwise, feel free to take a picture of this so you can use it as a table that you can write up on your own, or if you have enough time while I'm talking through it to write it up. Okay, so metals are thermal and electrical conductors compared to non-metals, which are poor thermal conductors. And metals are used in electrical conducting wires. They're shiny, metal luster, they're malleable and ductile. This just means that they're able to be bent and stretched without breaking. They usually have a high melting point, high density, and their magnetic properties are only seen in 3: ions, cobalt, and nickel. Non-metals make good electrical insulators. They're not malleable or ductile, and they include elements such as sulfur, phosphorus, nitrogen, and oxygen. So all the ones on your right. Metalloids have non-metallic properties. You can distinguish them that their conductivity increases as their temperature increases, compared to this where it's just standard. The opposite of what happens in metals, and this is known as semiconductance. So they are called semiconductors, and they're used in digital electronics such as computers, and they include elements such as silicon and germanium. Okay, so I hope you all like The Incredibles, because I love that they came out with the second one, but I hope you enjoyed that as much as I did. Okay, so some important definitions. What is an electrical conductor? It's a substance that allows an electrical current to pass through it. A thermal conductor is a material that allows energy in the form of heat to be transferred within the material without any movement of the material itself. An insulator is a non-conducting material that does not carry any charge or energy, and semiconductors behave like insulators when they are cold and like conductors when they are not. Okay. One way to further divide metals is to divide them into magnetic and non-magnetic. So the definition of magnetism is a force that certain kinds of objects, which are called magnetic objects, can exert on each other without physically touching. A magnetic object is surrounded by a magnetic field that gets weaker as one moves further away from the object. So a metal is ferromagnetic if it can be magnetized. Okay, so this is going to be the part where I'm going to give you some time to go over questions. Just going to answer these questions. We've got this table to match, and we've got saying what makes it able to carry out its function, and then this one as well. So what I will do is I'll leave this one up for about 2.5 minutes so you can complete it or take a picture if you need to, and then I'll put this on for about a minute, and then I'll go through the answers. and welcome to going through all these answers with you. Okay, so let me grab the questions. So hopefully these weren't too hard and you're feeling a lot more confident in these concepts. So name 2 materials that are good thermal conductors. So they've given you the thermal conductivity, so you would obviously choose the 2 that have the highest. So that would be your silver and your stainless steel. Then the next question is name 2 materials that are good insulators. So that would be the exact opposite. So that would be your polystyrene and A. So explain why red brick is a better choice than concrete in building homes that need less internal heating. So this question took me a while to actually read properly, but basically what they want to know is why would you build a house with red brick so you wouldn't need as much internal heating? And the reason for that is it would not be a good thermal conductor. If it was a good thermal conductor, what it would mean is that anything you put inside the house would immediately go outside the house, so your house would be cold. But at the same time, you don't want it to be too insulated because then you kind of suffocate and the heat never leaves. So the reason why it is good is because it's not a very good conductor. Okay, but it does still conduct. As you can see, it's 0.69. So it is a lesser conductor than concrete. So a concrete house would be colder than a house with red brick. Does that make sense? Next, stainless steel is good for making cooking pots. So stainless steel has a very high, well, not as high as silver, but a high thermal conductivity. So this means it will allow heat to travel through it. So the reason why it's good for cooking pots is that when you put it on the stove, the heat will transfer from the bottom through it into your food and it will cook your food. So it makes a good cooking pot. Okay, next one. Question 4. We have to match the columns. So iron is going to be with an element, so D, 1D. 2 is going to be with a compound containing 2 elements. 3 is a sugar solution, so it is going to be with E because it's a homogeneous solution. 4, mixture, sorry, not solution. Sand and stones would be B, a heterogeneous mixture. And 5 is steel, which would be an element. So, oh no, it wouldn't be, it would be a metal alloy, sorry, it's not an element. Whoopsie. Been a long day. So, for each of the following elements, say what properties of the material make it important in carrying out its particular function. So, tar on roads. Why do we have tar on roads? Purpose is friction, and I'm sure you've encountered friction before, is to stop cars going too fast or allowing them to brake so that there's less accidents as such. Iron burglar bars. So, iron is very durable, which means your prisoners can't escape. Plastic furniture, so that is also durable, believe it or not. Metal jewelry, just because it's shiny and everyone loves shiny jewelry. Clay for building it's easily molded, so you can have different types of clay structures built. And cotton clothing it is fibrous, so that allows things to breathe. Okay. That's why they often say a lot of athletes should wear cotton socks, or if you work out a lot, to wear cotton socks because they allow your feet to breathe. Okay, and then the next section, hopefully you had a chance to complete this as well, so they want the names. So we've got sodium, we've got bromine, so it is sodium bromide. Then we've got barium, and we've got NO2 is nitrite. Okay, NO3 is nitrate, so it's barium nitrite. Then the second one would be sulfur dioxide. And the next one would be sulfuric acid. So that is one that you will have to know. You could have said, I suppose, dihydrogen sulfate, but sulfuric acid is the correct answer. Give the formula for each of the following. So they want iron 2 sulfate, so that would be FeSO4. Boron trifluoride, so we've got B, and we've got F with a little subscript, 3. Potassium permanganate, so that would be your K, MnO4. And your zinc chloride would be Zn for zinc, Cl2. Okay, so I didn't want to add any more further concepts because this kind of sums up this whole main area, and then next week we can go on to further topics. So I wanted to introduce something called rapid fire. Okay, so we didn't do this in the first lesson, but I think this will be beneficial. So what I'm going to do is I'm going to put up a couple questions, and then I'm going to put on a countdown of about 15 seconds, or depending on how long the question takes, and then I'm going to wait for you to answer them, and then I'm going to give you the answers. So this is just a little more interactive. Okay. You don't have these in your worksheets just because I did want this to be almost like a quiz that you haven't seen these questions yet, and just so you can keep track and see if you've covered everything.
We are surrounded by countless substances. Some are pure, but the large majority are formed by mixtures of two or more pure substances. Pure substances have a homogeneous appearance. Each pure substance is characterized by having specific properties that distinguish them from all other substances. In contrast, mixtures do not have specific properties. Their properties depend on the substances, or components, that form them. The components in a mixture can be extracted using appropriate separation methods. Depending on their appearance, mixtures can be heterogeneous or homogeneous. The components in a heterogeneous mixture can be distinguished with the naked eye and are not evenly distributed. The components in some of these heterogeneous mixtures can only be distinguished using a light microscope. This is the case of colloids. The components in a homogeneous mixture, or solution, are evenly distributed, so they cannot be distinguished, not even under a light microscope.
Okay, and that brings us to the end of this second lesson. So I know it probably wasn't very hard, and it was just a lot of basic understanding, making sure you do have the basic foundation so we can build on in the future. And I really hope you enjoyed the examples I set and the rapid fire at the end. Hopefully that made the little push at the end worth it. So we've come to the end. There will be a Q&A after this. So if you have any queries on anything that has come up, or if there's anything you would like me to work on for the next one, please make a note of it and I'll be happy to answer them. And other than that, this has been Tutorbox Live in conjunction with COVID-19. And I hope to see you for the next one. Stay safe, everyone, and see you next time.
It's not a matter of whether or not we can. Everybody can, but not everybody will. How to turn nothing into something. How tangible are ideas and imagination? Ideas that become so powerful in your mind and your consciousness, they seem real to you even before they become tangible. Imagination that is so strong that you can actually see it. You can actually see it. If somebody cannot see it when it is not here, then it will never be here. Start looking into the future of what you would like to accomplish, where you would like to go, the person you would like to be. Decide what you want, and then act as if you already had it. And that is to believe that what you imagine is possible for you. So the first step is to imagine what's possible. Second step, to believe. Now here's the third step, and that is to go to work and make it real. You now go to work and make it a movement. You make it tangible. You make it viable. You breathe life into it, and then you construct it.
You have a lot to offer. The fact that you're still here means that your business is not through yet. People don't do what they know in life, but what they do is they operate within the context of the vision they have of themselves.
So write and draw and build and play and dance and live as only you can. Make up your own rules. The rules on what is possible and impossible were made by people who had not tested the bounds of the possible by going beyond them.
You must change what's possible for you. You, and only you, are the subject that impacts the burning desire in your imagination. You are living and feeling as if your future dreams are a present fact.
Will it be easy? No. Will it be challenging? Yes.
So you got to prepare yourself. You've got to develop yourself. As long as you're breathing, you got some more work to do. There's something else for you to achieve. Guess what? You're going to make some mistakes. You're going to make a lot of mistakes.
So now go and make interesting mistakes, make amazing mistakes, make glorious and fantastic mistakes, break rules, leave the world more interesting for your being here. Make good art.
It is possible to start with nothing and become something.